so problem number 4 from your homework would also be another good examples to look at. So what we're looking at here is we're trying to solve again for the exponential equation 2 to the x minus 6 equals 1/8. And once again, on your own course compass homework, you should have something similar to this problem. So what I see here is picking from the same trick that we had in the last 3 examples, in the last 3 problems. Okay, I'm trying to rewrite my 1/8 right here into a power that has the same base as 2. So the point now is that I would like to rewrite my equation in a way that on the two sides here has common base. Okay, on the two sides have common base. So now what I recognize is 1/8 is the same as 1 over 2 to the third power. And so furthermore, that would equals to 2 to the negative 3 power. So we have spent some time talking about a negative power in class, right? So here you can see how you can use it again. So the right hand side can be written as 2 to the negative 3 power. Okay, so now that means my equation will become 2 to the x minus 6 equals 2 to the minus 3. And what's so good about that? Common base, again, common base 2 on the two hand sides. So you can just simply focus on the left hand side and focus on the right hand side just on the powers, and you set the two powers equal to each other. And now at this point the equation becomes much easier to solve. Okay, plus 6 on the two hand sides, that gives me x equals positive 3. And this is how you solve another example, nice and easy. So it's also worth it to mention sometimes, so I am now looking into problem number 5 of your homework. Every single one of them has a special little feature that's worth to mention. So this time you're looking at solving again for 3x equals 1 over square root 2. Okay, so at first, oh my god, things seems like all over, and we want to solve for x again. Right? And it's an exponential equation. What I noticed so far, and picking on the same trick that we've had in the last 4 problems, I would like to write the two sides of the equation here. I would like to rewrite the two sides of the equation here into something that involves a common base. I would like to show some common base here on the two sides. So what I have here is the 4 on the left hand side equals to a power 2 of 2. So I would say 4 equals 2 squared. Now the quantity 1 over square root 2 on the right hand side can be understood as 1 over 2 to the 1/2 power. And once again, as I have explained in class earlier, a square root also always can be understood as a 1/2 power. And so what I have here is 1 over 2 to the 1/2 power in the denominator. That would be equals to a 2 base 2 but negative 1/2 power. And so now I'm going to turn my equation into 2 squared raised to the x power. And once again, 2 squared is just simply the substitution for 4, and then equals to 2 to the negative 1/2 power, and all that 2 to the negative 1/2 power is just simply equals to 1 over square root 2 on the right hand side. And now we had a trick earlier. We had the same trick that we had kind of like the same situation in an earlier problem, where you have a number raised to a power and then being raised again to a different power. So what I can do on the left hand side is I can just simply multiply the two powers, 2 times x. Okay, and that will equals to 2 to the negative 1/2 on the right hand side. So now once again I have just brought my equation back into something that's shared, that has a common base on the two hand sides. And so now I can just simply take my power on the left hand side, set it equals to the power on the right hand side, and here I have my equation. There I have my equation to solve for x. And so at this point to solve for x, we just divide both sides by 2, and that gives me x equals negative 1 over 4. Okay? Problem number 6 is giving me an equations that can involve some maybe a little more work around. However, it's still not going anywhere from the trick that we have learned earlier. So we have 9 raised to the power x plus 6, and that equals to 81 raised to the power x minus 4. Okay, and so now once again we would like to solve for x. And once again, same trick. We would like to rewrite each of these base on the two-hand side here into something with common base. So now 9 itself is the same as 3 squared. Okay? 81 is the same as 3 to the 4th power. So now my equation can be turned into, the left-hand side can be seen as 3 squared raised to a power x plus 16. Actually x plus 6, sorry. And then equals to, on the right-hand side, it appears as 3 to the 4th power, all quantity raised to the x minus 4 power. Once again, we have had a problem like this earlier, where you have a number being raised to a power, and once again being raised to a new power. So what I have here, I can just simply multiply the 2 with the x plus 6. Okay? And then on the right-hand side, the powers will be 4 multiplied to x minus 4 quantity. Okay? So once again, now I have brought my equation back to something that has common base on the two sides. So now I can just simply take my power on the left-hand side, set it equals to the power on the right-hand side. Okay? And here, this last equation here is once again, it should be easy to solve for. I'm going to distribute the 2 on the left side and distribute the 4 on the right-hand side. So I'm going to end up with 2x plus 12 equals 4x minus 4. Okay? I was just simply doing that distributive law. 60 the end of it. Okay? So what I'm going to solve for this problem, I'm going to add 16 both sides, and at the same time subtract 2x from both sides. And that gives me 2x equals 28 on the left hand side, divide both sides by 2, gives me 14. That's how I solve one more exponential equation. Okay? And so once again, what happens when you're running into a power where it looks a little out of ordinary? Say, in problem number 7, okay, we would like to solve again. Solve, we have e to the x plus 8, that equals to 1 over e. So keep in mind, don't let that challenge you so badly. I mean, don't let that scare you away. The e here, it's just one legal number out there. Even though, like I explained earlier, e equals to 2.718, but this is not the point. Whatever that number is, it's just one completely legal number. So what I can see is 1 over e. I'm going to rewrite it as a power base e. So 1 over e equals e to the negative 1 power. And that would give me, the equation that would become, so solving for x here, the equation would become e raised to the power x plus 8 equals to e to the negative 1. And once again, at this point, I am seeing common base on the two-hand side. So what I have here is I can just simply take my x plus 8, which is the power on the left-hand side, set it equals to negative 1, which is the power on the right-hand side. And here I produce for myself a new equation. And solving this equation here is easy. Subtract 8 from both sides. And that's x equals to negative 9. And that's how I solve that problem number 7.